Good, very late morning to to all, and thanks for having stayed until the end. Here in this talk, I will have the pleasure to conclude this ALTIUS session with what we envisage for the geophysical validation of the ALTIUS Level 2 data products. The plans are being prepared by a team at the Belgian Institute for Space Aeronomy and colleagues at ECMWF, NASA Goddard, ECCC, and University of Toronto under supervision of our ESA colleagues at ESTEC and ESRIN. I will start with requirements for the validation and then move to the data and methods and tools we plan to use, and then conclude with some details about the EO call just introduced earlier by Daniel. So mission requirements and user requirements, actually you have already been introduced to them several times, I think, during this conference. Basically, ALTIUS is to be an operational mission, providing long-term monitoring of ozone or contributing to this. And as an operational mission, as part of the ESA Earthwatch element, it is to offer a user-oriented solution with near real-time or at least operational routine facilities. The targets for the mission requirements and user requirements, the GCOS implementation plan was mentioned, the ozone assessment of WMO UNEP, other requirements of WMO for atmospheric monitoring and forecasting, and the CEOS interoperability requirements for the constellations. If we move to the validation requirements, so we have to do actually the usual business, so to validate the geophysical quantity value, so here primary ozone, but also the vertical profile of concentration of other trace gases. Validate the uncertainty estimate associated with the data product, retrieval diagnostics to check the information content and other things like this. To check the dependence of all the results on the influence quantities, and here in the table we have identified solar zenith angle, loss azimuth angle, obliquity and beta angle of the star occultations, and other parameters which are usual for that kind of activities. And also at the end, verify the effects of the ALTIUS data quality flags and recommendations for data usage. The validation protocol will be very classic, the one we developed nearly 10 years ago in the CEOS framework, so a framework to establish validation protocols. And this one was developed for nadir profiling, so much more complicated with a very pathologic vertical averaging kernels and dependence on influence quantities. So this will be a little bit easier to apply this, and this includes not only data comparisons, but also analysis of retrieval diagnostics, kernels, influence, information content, and things like that. The pathfinder for the operational routine part of the activity is the ATM Mission Performance Cluster Validation Service, currently in operation for the ESA Copernicus Sentinel-5 Precursor Tropomy mission. There are different functions, monitoring on a routine basis the S5P product health, but also maintaining data quality in documentation, be involved also in the evolution of the retrieval algorithm by providing validation diagnostics and things like that. And if you are interested in more details about this routine operational service for tropomy, you can go to this website where we operate this validation facility with the automated validation server. The validation server, if you go to this other address, you can select a data product, and then you access to graphs and tables with the validation statistics calculated on the fly. So this is really permanently updated automatically. And for the ozone profile, so we have, as you can see, automated and also not automated but in-depth validation of nadir ozone profiles in that case, with a chi-square sensitivity, offset, resolution estimates and things like that, in addition to the data comparisons. We need ground-based data. They will be the reference as classically. We plan, of course, to use ozone sound LiDARs and microwave radiometers contributing to the networks contributing to WMO Global Atmosphere Watch, so with the certification procedures, the traceability to SI and so on. Two networks here are represented, ozone sound and LiDARs. It's quite small, but below you can see histogram with the timeliness of data delivery. For an operational mission, we target data delivery within 1 week would be perfect, but 1 or 2 months are still okay. And for the ozone sound network, that's okay. For the LiDAR network, we are missing heavily LiDARs in the polar regions. And for this reason, we would like to set up a dedicated measurement campaigns to enhance data acquisition frequency, if better collocations, improve timeliness of FRM data delivery, especially in the Arctic and in collaboration with our Canadian colleagues. Cross-validation with other satellites is, of course, a must-do. We intend to do the classical things, a comparison of data pairs, zonal means, use of ground-based networks as a transfer standard, operational and in-depth, so offline, and also check the interoperability requirements, well, if we are compliant with the sales requirements for interoperability of the constellations. Cross-validation with other satellites, you have already seen that kind of graph of chart several times. We try to identify the best missions to do this on an operational mode, and we went to an agreement with NASA Goddard to have a strong collaboration with GPSS2 ARMS LIMB. We will do the same for Sage 3 on ISS. The other instruments would be, of course, very interesting, SFTS and others, but of course they are aging, and the operation in this time frame is not guaranteed. Something we are thinking about, but still thinking about, is cross-validation with native satellites. They offer a very good advantage. They have a complete global coverage of the sunlit side of the Earth. So that will be the opportunity, if we do that, to detect features not detectable with LIMB and solar occultation satellites and with ground-based networks, of course. We are thinking, of course, of the ARMS nadir profiling suite, and also Chopomi, which will be operating still in this time frame. The other satellites, I'm thinking of Sentinel-5, of course, but after due validation and insurance that they are providing good data. Collocation opportunities, this is something we are studying at the time being. ESTEC has developed an overpass prediction tool. We are still iterating on this, but the idea is to identify the best scenario, and also using this tool to give support to the people, the ground-based people, to, of course, to set up a campaign, but also to better coordinate the launch of ozone sounds or LiDAR shootings with the measurements that will be made by ALTIUS. For the LIMB, that's what is presented here. For stellar occultations and for the secondary products, nothing has been done so far, of course, because we have to know a little bit better about what will be done for those secondary products. Modeling and data assimilation, that will be also a very important part. ECMWF will do a battery of tests using their different systems, free runs, but also the first data assimilation. And the final goal, of course, is to ingest ALTIUS data in the CAMS integrated forecast system. BASCOE, the in-house 4D-VAR assimilation system, will also be used to do the battery of tests and at the end of data assimilation. ECCC will do some modeling studies, and they already do some satellite intercomparison using model as a transfer standard, and they will be involved with that kind of activity. And finally, we have also OSMOS, comparison metrology simulator, which is able to estimate the collocation mismatch with the natural variability effects, to make some correction for the NO2 diurnal cycle and other things like this, and that will be also very useful to support the data comparison and their interpretation. The objective, complementary insight into ALTIUS data quality, detect quality features not accessible by data comparisons, validate the uncertainty estimates and correct for denial cycle, and already start and be ready for the data assimilation, operational data assimilation, and start the applications. The overall validation operations and organization, we are thinking about a mission performance center like the one developed for Sentinel-5P and the atmospheric missions of Copernicus, with different tasks performed by different teams. So this is actually very classical as well. Level 1, level 2 verification performed by the data producer, who are the experts. A core validation performed by the small team, and you have seen actually the team coming from Belgium, Canada, and ECMWF. And then start of validation task with operational validation system for routine operations, a closed loop between ESA, the level 1, level 2, well, all the validation teams. Communication is extremely important, especially during commissioning phase and the first year of operation. We intend to start an initial offline uptake of an assessment of the first ALTIUS data already in phase 1 for ozone, aerosols, and solar occultation NO2. And later, and also involvement of user services, BASCO, ECCC, and ECMWF in the early phase. And later, complementary activities to be proposed by external teams as well, responding to the ESA AO call to form an ALTIUS validation team. The AO call, just introduced by Daniel, so something very important to be sure that there is no misunderstanding. In NASA, there can be AO funded by NASA or other agencies. Here, the principle is that ESA support this announcement of opportunity, meetings, the general organization, but the funding for participating teams is to be found mainly through your national agency. It's important to realize that. The objective of this AO call is to open the ALTIUS CalVal to the international community, to the wider range of validation activities and data sources, to enhance the validation of ozone already covered by the core team, but with additional data source methods, in-depth, very rigorous studies already during phase 1. Solar occultation and NO2 and aerosol products also starting during phase 1, and then carry out the validation of other data products during phase 2. The secondary products will be validated mainly through the AO projects. Of course, foster exchanges among the validation community, instrument and algorithm experts and core users, and to promote early use of ALTIUS data. The secondary products, you have already seen the detailed list presented earlier. Validation resource, we have, of course, the classical ways to validate the different products using ground-based instruments from different networks. Satellite profilers will be also key players in this game. Some projects might currently, like the FM4DOAS, could also participate in improving the NO2 and BRO profiling from the ground to do also that kind of validation. Coordination with balloon campaigns could be envisaged, for instance, Gloria, so synergies with other satellite missions. EarthScare, another ESA mission dealing more with aerosols, could be very beneficial for the validation of aerosols, and also just as a pathfinder for the organization of the AO. And then diurnal correction tools and other modeling activities in support. The last slide, the tentative schedule, also already introduced, but it's more from a validation point of view. So the call will be released, you have seen, in early 24. The idea is to have proposals submitted and also notification of acceptance before the summer. Because we know that to get funding from the national agencies, people have to apply usually during or just after summer to have a possibility to get funded the year after. In 25, we will have 2 validation workshops for coordination, scientific activities and rehearsal with test data files and things like that. The launch in March, hopefully. There will be a review of the results of the phase E1, the commissioning phase for ozone, NO2 and aerosols in September 26. And the phase E2 validation will start after that, with consolidated validation of ozone, aerosols and occultation NO2, and the validation of secondary products, and later, of course, validation of reprocessings when we have evolution of the algorithm, of the calibration, and so on. And I think I will stop here. I thank you for your attention.